Hey everybody, I wanted to make a video on my AnyCubic Kobra Go 2 printer. I've been using this thing for a year and a half now, and honestly it's taken me up till this point to finally produce really good prints. And this is the biggest print I've ever done. Look how good that looks. There's almost no rimming or anything, which is where you get the horizontal lines across it. They're very obvious and thick. Basically, you can see there's just a little bit of it right there, right where I've centered the camera, that spot, and the rest of it, everything's really consistently printed horizontally, and that's pretty much going. I just want to go over how I managed to get this printer to print so well and so consistently, because it genuinely took a year and a half of tinkering, mostly passively, to get it to work. First thing is airflow in the room. It's extremely important. So in this case I have this vent open, but if you look, the louvers are pointed still away in kind of this direction. So when I have the printer like this in my basement, the airflow is going this way and it's not hitting the printer or interfering with the print. In terms of plastic, just use PLA. If you use ABS, that's more toxic to breathe basically, because that's actually a synthetically made plastic. This PLA stuff is made from either corn or soybean typically, I believe, or some other plant matter, so way more safe basically. Not sure how they dye it exactly, but it's way healthier to inhale compared to ABS. Not that you want to breathe stuff in, period. So if you do have ABS, everyone in the community recommends you have an enclosed printer that has a really good filter, like HEPA filter for dust, and activated carbon layers as well for absorption of different chemicals and things that are volatile in the air basically, so they want to actively react with stuff. You have to catch that too. With this PLA, there's a little bit of smell produced, but not much, so that's pretty nice. Another thing is you need to dial in the temperatures and stuff correct. I have my bed set to 60 Celsius. And you're going to notice I have the speed of this printer set to 60%. That is pretty much a maximum printing speed of 60 millimeters a second. And it just looks fantastic. Look how smooth that is. It's unbelievable. Another thing is the temperature here. You will eventually learn what's too high. If it's too high, the stuff will basically ooze out too fast while it's printing. It'll be over extruded, and basically it'll be getting these weird peaks and things, or it'll look actually kind of globbed when it's printing. That can be caused by that. Another way that can be caused is having the print head too high off the bottom of the print. So let's look into that. Our Z offset number dictates that number basically. If you move the printer, it will change this value every time. When I had the printer over there on that brown table, boom, over there, it was negative 0.44 is what I had it set at. When I moved it over here is a better permanent spot away from my computer stuff and away from the draft that I needed to have happen to get the basement condition enough basically. So it had to be moved here. On this table, I had to put it to negative 1.34. And it's mostly dictated by the surface it's on. The other thing is, even though this is a very solid frame, it's a very nice construction. Every time you pick it up, it will misshape in just a little bit on a very small scale, because all materials in the world will give a little bit when you put force on them. So that's normal. This isn't like an abnormal thing to happen where the things get changed on tolerance a little bit. So when you put it in a new spot, you do have to find that setting, and that can be a little time consuming, but I got good at it. And then basically the way you do that is you go into settings and you run the auto leveling feature, and that pretty much zeroes it out pretty close by itself. And then you start printing a drawing that has a wide base. Like the owl print that comes with this printer is great, but something else that just has a big base you can find as a first layer is nice. And you just slowly start dialing this downwards if you need to, until you find the sweet spot to where the ink is actually, if I can find it, you can see it's actually layered on top of the bed. You don't want the nozzle digging into the bed. You can see there's a depth there to that. See, it's not like perfectly flat, but it's flat with the bed, it's actually above it a little bit, like it's allowed to protrude upwards, because you're adding height with each layer. If it's too far down, it'll look like it's squished and everything and look weird, basically, and you just want it to look relatively flat. There's countless videos online of how to determine this. Some people are using like pieces of paper and stuff and they slide it on here. That method's ridiculous. You just need to move it downwards until the plastic starts contacting with the bed a lot and isn't like moving around like crazy. And then you dial it in a little bit better if you can. And then when it does the second pass layer for when it's filling in the drawing, then that layer looks like it needs to be printed on top of the first one and not grooving into it. And it also should not be so high that it's like collapsing basically. So that's something to note. But there's lots of videos online how to tune things in like that. You kind of have to have an eye for it. But you definitely don't want to go too low by accident because you can destroy these beds. So this is going to get into more of the maintenance part of this printer basically, which is super low. These beds can easily last a lifetime of the printer if you take care of them. The way you do that is you don't use scrapers and stuff to like, get the print off when you're done. You just turn the temperature of the bed down to 0, and it turns the heating element off, obviously, when you do that, and it will start cooling down. When it hits about 50, the drawing will want to kind of start coming off because the plastic will contract at a different rate than the bed, and they'll basically unadhere from each other. And then that's way easier to get it off. You don't want to pull parts off when they are still warm. If you do that, they will warp. I've done that multiple times. I'm sure I can find an example for you. Basically, if you heat them up a little bit, you can kind of warp them back into shape real quick, but it's still not going to be perfect, so you may as well redo it if you accidentally do that. And the other way a bed can get killed is if you have this nozzle way too far down. It is metal. See that? This thing is very powerful. These motors can easily scratch the crap out of the bed, and people have done it online basically multiple times. When you're adjusting this Z height, you don't want to go too low basically. You gotta be very careful when you figure that out, because if you scratch the bed up, you can't use that spot anymore. Now what's good is, let's say you do ever mess up, right? And you mess up this really nice reusable bed. Well, you can actually change the load coordinates of where it starts printing to a different spot. So let's say theoretically it gouged across like this to the middle. That would be terrible, but if it did happen, you can go into your slicing software and you can change where it prints instead. So I can have it print here or in the back area there basically. You can change the load coordinates around so they avoid that spot that got damaged, and you can keep using a nice flat plate like this. Another thing is, once it's cooled down enough, it can't burn your finger. And then when you do that, you just pop your finger around the edges. So here's a nice Honda symbol printed out, right? So this is the way it was printed up. You should keep your fingernails a little bit long, especially if you're doing 3D printing. You go around the edges just a little bit and keep pushing. Not hard, just push a little bit. And if it's cold enough, it'll want to just come off. And then once it comes off, then you're good. Alright, I want to talk more about maintenance of the bed itself, basically. Especially how to get to print for the lifetime of the printer and everything. Obviously not scratching it is important. Another thing is, I just leave it on the bed. A lot of people, what they'll do is, they take this off because it's magnetically attached basically, and they'll flex it around to get the part off when they're done. There's literally no need to do that at all. And every time you do that, you have to readjust the printer again because it's knocked out of tolerance. Because you literally just warp the bed around and put it back on, and it's sitting in a different spot on here too. So there's literally no reason to do that. Just turn the bed off basically, the heater, wait for it to cool down, and the part will want to detach basically. If it's tall like this, you can actually try to maneuver it around in different axes until it feels like it wants to start pulling off, and then it will just want to suck off basically. Okay, this is not that hard, you just gotta have some patience. And anyways, if the part's still warm and you're trying to rush the process, it's gonna warp anyways. So, I mean, I have tons of different plastic examples. Here, let's try to find one. So, example of plastic warping. When I had a failed print, or I just wanted to end this and then take it off because I was calibrating the printer. Obviously this is warped here. This is because this was still adhered to the bed, which was really warm. And when I pulled it off, the plastic changed shape and then cooled and is now holding this shape. If you wanted it back up again, you can make it pretty flat, but it's never going to be the same. So yeah, kind of fun. Another big thing is with these printers. See how this Honda keychain here, this is the old variant I tried, kept jumping like this? And this one's perfect. What's the thing I changed? Well, all of my prints were basically having this problem. And I also noticed on the rails underneath the printer itself. So let's move our little light down here, right? The rail, the wheel is sliding on right there, was crazy dusty. You know what that dust was? It was the rollers and rails eating themselves because I had everything too tight. Not joking. You don't want it too loose because then the bed will be able to shake and your prints will be really inconsistent, basically, especially on that axis. But you also don't want it too tight because then you're going to have all sorts of grinding. You're going to destroy the wheels in the printer, so that's not fantastic, obviously. And if it's so hard to move this bed back and forth, then literally the stepper motors give up occasionally, and the printer doesn't realize it, and it just continues to print after it's skipped, basically, because it couldn't move back to the position it wanted to, and it starts continuing to print offset by like half a centimeter, or in this case, like a whole centimeter. And I kept having this happen on a lot of different sized prints, even big ones. So it was a pain to use the printer until I realized that was a thing that was happening. And it wasn't until I had a lot of dust built up down here that I realized it was because the wheels were too tight. Another thing that helped reduce that issue was I greased all the rails with silicone grease, basically. It's kind of like a gel, and it's used a lot in electronics. It's more dilithium grease is the proper verbiage, I guess, to use for it. It kind of looks like petroleum jelly. I don't know if you can see the ribbon in it. This only, there we go. See, there's like a Vaseline look on the rails. So the camera doesn't show it perfectly, but it looks like I've coated the rails totally with Vaseline up and down them. That is the dilithium grease normally used in like some electronic projects and stuff that I use as lubricant on this printer, and I found that to be the best thing. It's really nice and thick. It's not super runny like the stuff they give you in the package, and I don't really have that dust creation issue anymore. And obviously this is a huge print, and I just don't have that kind of buildup. Just to prove it. See how clean that is? I have not touched it, right? There's no dust buildup other than just some fuzz that might have been in the air that has gathered on here, so that's that sort of thing, basically. But the rails and the wheels and stuff are not really wearing anymore because there's this layer of stuff between them. That's the whole job of lubricant in the first place. And I literally put a bead of it on my finger, and I went on each side interior of these rails, right? This side, and this side of it, up and down. And you can make this computer here move this vertical axis up out of the way. You can get the bottom portion too, which is where it's going to be for most of its life anyways. And just for fun, I did coat the wheels a little bit as well, just to get that going, so there's no initial dry components to steal a little bit of lubricant from the rails from the get-go. And this has worked great. I mean, it's dilithium grease. It's kind of pricey per tube, but you don't use much of it at all. I've only had to grease it once now, and that was almost half a year ago, basically, and that largely reduced that problem to the point where I don't have new dust buildup, because nothing's really wearing down much anymore, which is what you want. You want these to last for as long as possible. So that's kind of fun. Now to get into what printing filament I use. This printer prints slow, and that means you can use cheaper filaments. Some of the expensive printers that print fast, you have to buy a specialized, more expensive filament to do that. This one is an Ender PLA one. I'll turn the flash on real quick. Flash is on so you can see this now. It's just 1.75 millimeter filament, and this case in it was literally 2 kilograms worth of filament. This one was the black spool I've just loaded. And I've used a lot of my white spool, which is in here. Ta-da! Very nice. This stuff is rated, it says it right on the sticker, right, for 40 to 80 millimeters per second. This printer is at 60. Basically, you can't go faster than that, or the prints look like junk, basically. Not because of the filament, but because the printer itself is not rated for that high of a speed to produce really good prints. It needs to be 60. They even recommend that, but at the factory, So that's how that is. Basically, this is the black spool I've used a good amount of, basically. But I bought this originally when we got the printer a year and a half ago, and I printed tons of stuff. So the 1 kilogram rolls do go a long way. I recommend doing that. Basically, just going that route. You can buy. I got both of these together for $20, so that's excellent value there. That's definitely what you want to aim for, is about $10 a kilogram. They do sell starter kits that you might accidentally get into that have multiple colors in them, but there's not much filament of each color, and that's cool if you're doing really tiny pieces and projects, basically. Or if you're doing big things like this, well, guess what? You run out of filament, and it turns out if you run out of filament during a mid-print like this, it's game over. You have to throw it out and start over, because this printer is not good at pausing or stopping and then resuming the print again, because there's an obvious horizontal defect that forms, and in a lot of cases, actually, it's so bad that it hurts the structural integrity of the part, and the visuals are also not good either when it happens, basically. So the idea is you don't want to run out of filament. This 1 kilogram spool, I can confidently do big parts like this, and it's not going to be a huge issue. This one is likely 333 meters worth of plastic or so, because it's a 1 kilogram spool of 1.75 millimeter, what's it called, filament. And this part will use about 23 meters of it, basically about 10% of the spool. Some of those mini spools you buy might just be about that much plastic. So if there's any sort of error, basically, you don't have room for error and you run out of filament. Like maybe the estimate was wrong and ended up using 24 meters. Well, congrats, the end of the part's not done now. So it's way better to use these longer lengths and call it a day. Because the other thing is, if you have a bunch of small spools and stuff, basically, there's not much you can do with the ends of the spool when you don't have much stuff left. So when you have big spools like this, you don't run out of stuff as frequently, and you're not going to have limitations with what you have in stock more frequently, because when you have like 10 meters left of it or something, basically, which you pretty much have to measure out yourself, you're kind of limited in what you can do. So if you have a ton of spools that are all 10 meters, that still doesn't mean you can print out a project this big. That only means you can print out small projects. So I recommend just getting the big ones and just doing that and being done and call it a day. The other thing is humidity storage for these spools. So there's a lot of printer talk online about how these have a shelf life of like a few months or so once you open the package and they start getting exposed to humidity, blah blah blah. And no, it totally depends on how humid the environment is. This basement is controlled constantly around 38% humidity to 50% humidity. These are a year and a half old. It still prints super well. Okay, it looks great. There's no issues. The only time I had humidity issues was I initially had this printer set up in my college. The humidity in my dorm was 100% for multiple times for days straight. And what happened is some of the prints just wouldn't print right. I can't really describe it. They just didn't look the same compared to my other ones. And it was the humidity in the air. I don't even know if this stuff had absorbed it yet, but the actual printing itself, at least, was definitely being altered because of the high humidity. So having an environment around 50% seems to be ideal. Right now it's winter. It's about 40% down here, and looks great. So no worries there. They also sell dryers for this stuff, basically, to try to recover it if it does get too humid, which is ultimately what decides the life of this stuff. You don't need that. All you need is a fan, basically, to blow air specifically that's lower humidity across it. You don't need some sort of specialized dryer to prepare the filament. That's silly. If you have a room that has a known humidity, then this will go into equilibrium with the humidity in the room as long as there's airflow across this. Even if there's not airflow and it's just sitting there, eventually it will come into equilibrium with the relative humidity in the room. There's no need to get a specialized dryer. That's just kind of goofy. You just repurpose whatever fan you have in the house to try to recover the stuff if you do think it got too moist, basically. So that's good to know. Another thing I should probably cover, which I kind of missed, was the temperature of the nozzle for printing. I may have touched it a little bit earlier in the video. right now it seems to be 197 Celsius is good. When I had it higher than this, it was getting really stringy and globby, basically, because it was just kind of over extruding, where the printer wants to push the ink out of it, not ink, but plastic. Kind of think of it as ink though. It wants to push it out at a certain rate. If it's way too fluid, it kind of just gushes out, basically, and then especially when it doesn't want it to, because I've actually seen this kind of retract stuff a little bit. Let's see. So you can see this turning, right? This is what controls the filament being fed, or plastic being fed, into the nozzle. So the part that controls that is way up here, basically. So if the stuff is way too fluid, it's not going to have super exact precision that it needs for stuff to come out right. If you're doing too little stuff, then the prints are really going to show a lot of sort of gaps between the lines. Alright folks, so now we're on the slicing part of the video. I really like this software, Prusa Slicer, and I'm using version 2.8, I think is what it is. So that's pretty good. I love this software. I recommend getting the newer updates if you haven't been using an older version. The newer version supports new stuff like stars, which is the infill pattern type. Stars is my favorite. This Kobra Go 2 printer does the best with stars. I used to do a sort of square pattern in the past, and I had a lot of issues with that. So stars seems to work better. You can set the infill amount here when you have the part loaded up. This exact cup is what's printing right now, right? I have it set to 5%, and that's fine for this case because the part itself has very thick walls. I'm going to show that. So we'll show the sliced view. And we can turn these layers on by clicking here, which is very nice. So here's everything on as going to print in the printer, right? Here's the orange layer, which is the external perimeter. We'll turn that off. Then we have the perimeter, so that's thick. Then we have the solid infill part, so that's also now turned off. Now finally we have left the infill. It's crazy. So we toggled this on and off, and you can see that's what all it's printing right there. So we're controlling, I believe, that variable with this. Let's check that. Right. So we'll make sure that changes. I have to click the slice now button when we do that. Yep, see, our internal fill number went up because we used more stuff. So we'll set that back down to 5. So for this part in general, the walls of it are very thick, obviously, so you can go down to 5%, and this does impact the amount of filament you use. So on the right side of the software here, it's really awesome. As long as you have it sliced, basically, then it will show you the amount of filament you're going to use. So this is about 10% or so, maybe less, of one of those new rolls used up to make this shape. So what it's estimating right now, because that roll new is probably 300-ish meters long. This is using 21 of it. So now you have an estimate of how much the part is going to cost to make, and it also tells you an estimate of how long it's going to take to print. Now in my case, we're running the printer slow speed. You're going to as well, so your parts come out nice, basically. So it's going to be a lot longer than what's on here, but this is going to give you a definite minimum estimate. So in our case, it's going to be a lot longer, probably 50% longer, and that's true. We're about 6 hours in of printing, and it's almost done. Now, getting into reducing the print time. When you reduce the infill, that absolutely reduces the print time. So reducing the infill amount massively reduces print time, and it saves you a lot of money on plastic, right? So when you're trying to reduce how expensive a part is to make, if you're trying to reduce the weight of it, we're trying to reduce the printing time, basically, and that also reduces wear on your printer, which is important, and energy usage when printing. Always reduce this number. A lot of times nowadays I use 5 or 10% for pretty much anything. I only use 25% for things that are loaded more, basically 50% for things that are super loaded and have very thin walls. So that's how that works, and that's how I decide that, basically. Another thing is you can adjust the scaling of your item so you can reduce the size. This print, when it was in its original size, was going to take like double the time, basically. So literally half a day to print in my case. I have reduced the dimensions a lot. So this software, you hit this unlock button and you can control the different axes together or independently. So I reduced the X and Y to the size of the cup I need to fit for that cup holder. And the Z, I reduced the height because it did not need to be as deep for the cups we're using. And you don't want that deep anyways in a lot of cases. So I reduced this a huge amount and I'm using way less filament. You notice right here, the number has jumped up again to 29 meters. And that's because I had the infill set high. Let's see what happens when we put this down to 5%, which I've set it to for this print in specific because it has very thick walls and it's not mechanically loaded a lot. Boom, 21. So now we're using 2/3 of what we were originally. About 30% reduction in material usage. That is awesome. Way less printing time too, basically, just by changing the infill amount. Obviously, if your parts don't have very thick walls, you can bump that infill up to like 10%, no problem. If it has thin walls, it's definitely mechanically loaded a lot. 25%, sure, no problem. If it's loaded a lot, has thin walls, for an extreme usage, 50% basically. That's why I set that John Deere fan 2 I made. Just kind of saying that because it's important, right? But I only do that at maximum. I don't go above 50%. Now, I do not recommend going above 50% with this printer because the problem is the infill star pattern tends to overprint itself if you do, basically, because it's just a way too dense of a pattern. And it prints out a good amount of plastic. They tend to start to collide with each other almost a bit because the stars are just so tight, basically. It's really unnecessary. And when you go above 50%, that's a ton of plastic. I mean, like, you're basically just like filling it in solid in the middle, and realistically you don't have that much plastic available to do that. So it's going to be really hard to produce some big parts without even running out of material, okay, aside from just being a super long print. If you're making really small stuff and you want it to be solid, I guess that's okay, but when you go above 50%, it tends to come out wrong because there's just way too much plastic involved. There's no air cavity for things to bleed into if there's a mistake internally or anything, and the part just looks like junk. So when you have it set to like 50%, you have enough gap. So here's like a star pattern base I did for a random, I think it was like an ornament or something, and you can see here, this is maybe a 10% fill or so, maybe 25%. No, not even, more like 10. And there's tons of air gap between here. If there's any sort of defect in the printing, the plastic can just jut out to the side a little bit. You can see it's not perfect. There's little bumps and stuff that stick out. If you set the infill to like 100%, there's no room for that. So then the part itself starts to print like junk because everything else pushes out to the sides, basically, because there's just no room now for extra plastic. That part, one of the layers got messed up just a little bit. You have to remember, these things are doing like probably millions of different movements to try to produce, especially big parts. There's only going to be a certain percentage of successful printed plastic spots, basically, and you're going to have some amount of error, basically. I mean, this thing's good enough to where it's probably 99.99% good, that sort of thing with printing things. Obviously now I've mastered the machine, so it's probably around there, but that very small percentage you have to account for. So if you have the infill set too high, it's gonna print weird. So keep it like 50% at most, basically. For all my stuff nowadays, I do 10 and 5%. I tend to jet up to 25% if something's especially thin and it needs a lot of strength for some reason. Only did 50 the one time for a fan I had to produce one for a lawnmower, where it had legitimately 1 layer thick walls on things, which is crazy. And the part gets high torqued all the time, so it needed to be high for that. And it came out fine, and it's still in use on that John Deere mower. So it's been about 15 minutes, and we're back now at the printer. I just kind of walked over to the computer for a bit to shoot that part of it. I mean, notice, look how good this looks. We're gonna come back for when this finishes. There's only a couple of little ribbing spots you see here. See how there's dark lines horizontally that go 1, 2, 3-ish areas, and the rest of it is a consistent color. That almost always has to deal with other things that printed weird on the printer. So on the back side of this print, there's actually 3 holes. I'm trying to maneuver the camera. Give me a second here. There's 3 holes. See them? Ta-da. those little ribs coincide on the same horizontal axis as those holes. So that just might be a printing limitation of this printer, or it could be how the print was exported by that slicer program to your printer. I pretty much find those unavoidable. When those stand out a lot, sometimes it has to do with your print settings, so you might want to try to change something a little bit. It did come out better, but I've pretty much eliminated them just because my print settings are so good, but they're not totally gone, and that might just be due to some limitations with the software or hardware, so that's just something to keep in mind. And check it out, my best print and biggest print of all time. Look at this. So here's results for you. And my advice is actually worth something, right? Check that out. And the bed is at 60 Celsius. So we're going to turn this bed off basically by setting the temperature to 0 as a target. It'll end up settling down at about 20 Celsius because that's the temperature of the basement. We see it took 6 hours and 13 minutes roughly to print this out. If you look at our plastic spool, we still have a very good amount of plastic remaining. And that's because I did limits on how much plastic I used by reducing the infill amount and by reducing the overall size of the project height-wise. I did have to make it a little bit wider. Actually, no, I did. Made it a little bit skinnier. So yeah, dimensions got reduced. Infill amount was reduced to 5% because the walls in this were thick enough, right? No big deal. So once this cools down enough, I will show how to remove things from this printer without problems. And so we're getting closer. You can actually hear the plastic making noise. Not that you can hear in the microphone, but it's starting to make noise as it's unadhering from the bed down here. So once it's fully unadhered, pretty much, we're going to be able to pull this off really easily. If I put my finger right here against the cup, this bed's not too hot now. It's still warm near here, so it's a little too warm for my liking. I want that to be nice and cool, so this does not possibly warp as I'm trying to take it off. As you can see right now, this is nice and flat, and it's going to fit cups correctly. If I pull it off and it warps and it immediately remembers that shape, that'd be really silly. So we'll just go ahead and wait a little bit longer for this to cool down more, and then we'll attempt to take it off. But I just heard it again, especially on this side. There's a lot of crackling noise, and that is literally the bottom unadhering from the bed here. So we'll go ahead and wait for that to happen more. Okay, this is fully cooled down. Let's go ahead and give this a go here. Check this out. Ta-da! Look at that. It just came right off. Look how clean that base is. Very nice. Yep, and that's ready to be reused again. We can just peel off the little black skirt, is what it's called, from the edges too. This is nice and lightweight.